Assalamualaikum and a very good day. This video I'm gonna show you how to develop circuit using a MultiSim Live. If you can see from the screen here, you just Google MultiSim Live and then you click online simulator. Okay, once you have seen the online simulator, you need to sign up by using your account. Once you already create the account, don't worry, it's a free. Okay, this is free versions. We use the free versions. Once you register your account, then you can directly click the create account, the create circuits here, but this button. Okay, later you might explore by yourself. I just show you some demo, the basic demo how to build a circuits, but additional features inside this simulator you can explore by yourself. Okay, as for demo, I would like to show you how to build this circuit in your lab sheet, figure 1A, which is a LR series circuits. Okay, as you can see in figures 1A here, we have a power supply, a square wave power supply, we have inductor, and we have a resistor, and then we need to measure the VRs there. Okay, let's build the circuit. Okay, to get a square wave power supply, okay, you in this simulator you need to choose these sources, click these sources and choose the voltage, the clock voltage here. Okay, and then what else we have inductor. So inductor, you must choose the passive device here. Click the passive device here, click the inductor. And we also have resistor. Click the passive device here, click resistor. Okay, and then of course we need to have ground as well. Then you can connect the wires there, or the jumpers there. Okay. Okay, once you finish, once you complete the circuit, then you need to check the parameters here. Okay, for example, in your lab sheet, the power sources that you need to use is a square wave. So you need to check the procedures there. What is the spec of the square wave there? Okay, once you finish your circuits there, you need to check back the parameter of all your components there according to the lab sheet. For example, your VS here. So your VS, if you see from the lab sheet, it's said that you need to use a 5 volt with a square wave of 1 kilohertz. So let's check here. So it's a 5 volts 1 kilohertz. So that's correct. This is already correct. So you don't have to change. Now you need to use 100 millihenry. So you need to check the inductor. So the inductor should be 100 millihenry. Okay, so you need to change this one by click this one. Okay, you just double click, then it appear the spec on your right hand side over here. So then you need to change this one into 100 millihenry. Okay, and then the resistance, then because the resistance you need to vary. I just show you when the circuit have a resistance value equal to 4 kilo ohm. Okay, so we change it into 4 kilo ohm. Double click this one and then change into 4 kilo ohm. Okay, so after that you can directly run the circuit. I'm sorry. Okay, I'm sorry. Before you run the circuit, okay, the objective is to measure the VR, or the voltage across this resistor over here. So in order for you to check the behavior or the characteristic of the voltage there, okay, during the charging and discharging, doesn't matter in the face-to-face or in the practical experiment, you need to use the oscilloscope. But by using this simulator, you just need to pick up this analysis and annotation here. Okay, you just click the voltage. Okay, actually this one is represent the positive probe of your oscilloscope. Okay, you put it here, a positive terminal probe of your oscilloscope, and then the negative reference or the negative terminal of your oscilloscope you put on the ground here. So this is a positive terminal, this is negative terminal. Again, this actually can represent two device. Okay, it can represent your oscilloscope, but if you have experiment that you need to measure the voltage across this VR, you can also use this one. But in practical, you can use either oscilloscope as well as multimeter. Okay, but in this simulator we only have this point or these features where actually it can represent either multimeter as well as oscilloscope. But in this experiment it represent oscilloscope because we want to see the changing of the voltage. Okay, if you are using a multimeter, you just can have one numbers only. Okay, once you finish, then you can click here to run the simulation. Okay, and then you can click the grapher here, because the grapher will represent the characteristic of this changing over here. Otherwise it's look like your multimeter where it keep changing. You don't know because the number is keep changing. So if you are consider this as your multimeter, you cannot see the reading. So that's why in practical we are using oscilloscope, so we can see the graph show the changing of this value over here. So in this simulator, that oscilloscope is represented by this grapher over here. So you click the grapher, then you can see the patterns there. Okay, this one is look like this interface here is look like your oscilloscope. You have this interface, but you just can click. For example, you already get the result. So if you want to see the charging and discharging in a single wave, then you can click a single over here. Okay, it does not appear as a single. So one way you can do is you change it into auto. You just click auto here. Okay, click auto, and you can display it clearly over here. Once you get it clearly, then what you can do is you can change the time over division over here. Okay, to change the scale. Okay, this one is the best one, or this one. You can choose, because you only want to analyze as this one, only a single wave over here, because this one represent a charging, this one represent discharging. This is where you get your your tau, your 2 tau, your 3 tau, as well as the discharging. You have a tau, 2 tau, and 3 tau. You need to find the voltage of that tau, 2 tau, and 3 tau. So one way you can use, you can just click a cursor there. You can vary the cursors there according to your tau. That is one way. Another way, you can also use the cursor like what have been mentioned in the lab sheets there. Okay, you can use the cursor there, the feature cursor. You just type x-axis, and then you have two cursors there. So you can put one here, okay, at the 0 there, and then you put another one, which is, because the cursor here, two cursor here, you have the value there, but what we want to see is the delta x over here. So if the one cursor at C1 at this point, another cursor at this point, the difference between this and this in x-axis is represented by this delta X. So then you can know, after you do a pre-lap, you know what is a tau, you just vary the C2 according to your tau, then you take the voltage there, the voltage of that cursor 2, okay, as your as the value in the result there. Okay, I hope you can explore that later. And other information or other things you might explore by yourself, and thank you.